Hey everyone, prepping for a tech interview. Maybe you're just looking to boost your Python skills. Or hey, maybe you're just curious what's hot in the Python world these days.
Always good to stay ahead of the curves, right?
Right. So we're doing a deep dive today into a DataCamp article, just came out in January 2025, all about the top 36 Python interview questions.
Oh, wow, 36. Sounds intense.
It is. Don't worry, we're not going through all of them, but we'll hit the ones that really caught our eye, from the basics to the stuff that'll make you think.
Love that. Got to cover all the bases.
Exactly. Okay, so let's start unpacking this thing. The article kicks off with, the classic, what is Python, and lists some of its key features.
Got to start with the fundamentals. It's a classic for a reason.
Right, so readability, that's a big one. I mean, I've heard people say Python code almost reads like plain English sometimes.
It's definitely designed to be clear and concise, easier to understand, easier to maintain. Big plus.
So beginner friendly, check. But what about its power? What can it actually do?
Oh, it's powerful, all right. So Python is an interpreted language.
Yeah.
Right? So the code is executed line by line.
It makes sense.
Which is great for debugging, by the way, because you don't need to compile that whole program before you run it.
Oh, that's nice. Yeah. Saves time.
Exactly. And then it's also dynamically typed. You don't have to sit there and declare all those data types. Python just figures it out as it goes.
So less for us to worry about. I like that. But the real power, I'm guessing, is in the libraries and frameworks, right?
Oh, absolutely. I mean,
right.
That's where things get really interesting, whether you're into data science, web development, you name it. There's a library for practically everything.
So adaptable, right. Tons of tools ready to go.
Exactly. That's what makes Python so versatile.
Okay, next up is a question about data structures. What are Python lists and tuples? Seems pretty basic, right?
On the surface, yeah. But the article really digs into a key difference here. Mutability.
Mutability. Okay, so I'm guessing this is more important than it sounds.
Yeah, it really is. So lists, those are mutable. Think of it like your grocery shopping list.
Okay, I can picture that.
You can add things, cross things off, change things up, even after you created it, right?
Makes sense.
Now, tuples, those are immutable. Think of it like a historical record. Once it's set, it can't be changed.
Oh, okay. So no sneaking extra cookies onto that tuple shopping list.
Exactly. Python will be like, nope, not going to happen. You'll get an error. And this whole mutability versus immutability thing, it comes up with other data types too, like dictionaries, sets.
So it's a big deal, but why? Is it just a trivia question interviewers like to throw around?
No, it's much more than that.
Yeah.
Understanding mutability, it's key for writing reliable code. Because if you change a mutable object, those changes, they can have a ripple effect.
Oh, like unintended consequences.
Right. Things can get messed up if you're not careful. But immutable objects, they're more predictable. They help prevent those pesky bugs.
So it's all about making sure our code does what we actually want it to do.
Got it. Okay, on to something that always makes me scratch my head, this one. What is the global interpreter lock, GIL, in Python, and why is it important?
Ah, the GIL. The GIL, yeah. It's a bit of a Python quirk, let's say. Often comes up in interviews, kind of a gotcha question.
Okay, so what is it? Break it down for me.
Well, in simple terms, it basically means that even if your computer has multiple cores, only one thread can execute Python bytecode at a time.
So it's kind of like a single lane bridge. It keeps things organized, but not so great when you have a ton of traffic trying to cross.
Perfect analogy. The GIL, it does make things easier, like memory management is simpler, thread-safe code is easier to write. But yeah, it can limit performance, especially for tasks that could really benefit from, running on multiple cores at the same time.
So a bit of a trade-off then. Sometimes efficiency comes at the cost of speed. Interesting.
Huh.
Okay, this next one sounds a bit mischievous. What is monkey patching in Python? Monkey patching. It sounds more complicated than it is, honestly.
Yeah.
It's essentially a way to change how code behaves, but you do it at runtime.
At runtime. Okay, so while the program's running.
Exactly. Imagine you've got this function, part of a module, but it's not quite doing what you need. So instead of going back and changing the original code, you monkey patch it. You swap it out with your own version right then and there.
That's wild. It's like doing surgery on a live patient.
Kinda, yeah. It can be incredibly useful, but definitely risky if you don't know what you're doing.
Powerful, but proceed with caution. Got it. Okay, let's shift gears a bit and talk about data science, which, as we know, is a huge area where Python is used. One question that comes up a lot is, what are the advantages of NumPy over regular Python lists?
NumPy, oh yeah. NumPy arrays, they're like lists on steroids, especially when you're dealing with, lots of numbers.
So what makes them so special?
Well, for one, they store data much more efficiently.
Mhm.
Leads to big performance gains, especially with those large data sets. Like, think about it. If you had to process like 1 million numbers, NumPy is going to be way faster than a regular Python list.
Okay, so it's like the difference between walking and taking a bullet train?
Exactly. And NumPy also comes with all these built-in functions for mathematical operations. It's like a one-stop shop for numerical computing.
That's awesome. Speaking of making data come alive, the article then jumps into visualization with this question. Which all Python libraries have you used for visualization? Sounds like they want to know if you can make those charts and graphs sing.
Data visualization is key.
Mhm.
Helps us understand patterns, tell a story with the data, right?
Absolutely. And Python has some amazing libraries for that. The article mentions a few, like matplotlib, Seaborn, Plotly, and Bokeh.
All great choices. Matplotlib, that's the granddaddies of them all. Super versatile. You can create all sorts of visualizations with it. Static, interactive, even animated.
And Seaborn. That one builds on matplotlib, right, making things even easier.
Yep. Seaborn is all about creating plots that are both statistically informative and visually appealing.
The best of both worlds. And then there's Plotly, which I know is known for its interactive plots. Perfect for, like, web dashboards.
Right. Zoom, pan, hover, all that good stuff.
And lastly, Bokeh. I'm honestly less familiar with this one. What's its specialty?
Bokeh. That's the one for when you've got those massive data sets, super detailed visualizations, perfect for web applications where people need to really dig into the data.
So many cool options. I'm excited to explore some of these more.
Me too.
Okay. Are you ready to step into the arena of coding challenges? I know these can be a bit nerve-wracking, especially in an interview.
Bring them on.
All right. So first up, can you remove duplicates from a sorted array? Now, this might seem pretty straightforward, but the article throws in a little twist.
Yeah, the classic in-place requirement.
Meaning you can't just create a new array. You have to work with the original one.
Exactly. It's like trying to tidy up a room, but you can't use any extra storage space. Gotta get creative.
Yeah. So how do you do it?
Well, the article uses a clever approach with, get this, 2 pointers.
Okay, 2 pointers.
Yep. One keeps track of where the next unique element goes, and the other just walks through the array, comparing as it goes. Pretty neat.
So understanding the limitations before you dive into the code, that's key. Great takeaway. Okay, ready for another one?
You know what I mean?
Okay. How many ways can you make change with coins in a total amount?
Oh, I feel like I've seen this one in like a math textbook somewhere.
Right. Classic dynamic programming problem. It's like trying to figure out all the different coin combinations you could use to pay for something, you know.
Everyday math.
Totally. So how does the article tackle this one?
They use a table, systematically storing the number of ways to make change for each amount, building up to that target, using whatever coins you have.
So it's like breaking the problem down into bite-sized pieces, step by step. Love that. And you know, even if you don't memorize this exact code, the way they break down the problem, it's super useful for other algorithmic challenges. That's what I'm taking away from this.
Totally agree.
Okay, that was a great warm-up. Ready to dive into some more advanced questions?
Bring it on. I'm ready for round 2. Welcome back. Ready to tackle some more of these Python interview questions.
You bet. Feeling pretty energized after those first few rounds. So what's next?
Okay, this one looks like a real brain twister. Can you explain common searching and graph traversal algorithms in Python?
That does sound a bit intimidating.
It's really about understanding the strategies for finding information within, data structures. Think of it like searching for a book in a library, right? You could go through every single shelf until you find it. But who has time for that? Algorithms, they help us search way more efficiently.
Okay, that makes sense. So what kind of algorithms are we talking about here?
Well, one that comes up a lot is binary search. It's super efficient for searching data that's already sorted. Like, imagine you have a phone book, right? And you're looking for a specific name. Instead of going page by page, you open it right in the middle. If the name you're looking for comes before the names on that page, boom. You can just ignore the whole second half of the book. Keep doing that, narrowing it down until you find it.
Divide and conquer. I like it. What about those graph traversal algorithms, BFS and DFS? I remember those terms from like forever ago, but could definitely use a refresher.
All right, picture yourself in a maze, right?
Yeah.
So with breadth first search, or BFS, you'd systematically check all the paths at your current level before moving on to the next one. Kind of like ripples treading out from a pebble you drop in water. But with depth first search, DFS, you pick one path and you just go as far as you can before backtracking to explore other paths.
So BFS is more about breadth, like exploring all options at a certain level, while DFS is about going deep, following one path at a time.
You got it. And they both have their uses. BFS is often used for finding the shortest path between 2 points, while DFS is great for things like, maze solving or detecting cycles in graphs.
Okay, that clears things up a bit. Now, onto a question that I'm sure every Python programmer has encountered at some point. What is a key error in Python, and how can you handle it?
The dreaded key error. I've definitely seen my fair share of those.
Mm-hmm.
It happens when you try to access a key that doesn't exist in a dictionary.
Mm-hmm.
It's like Python's way of saying, hey, what you're looking for, not here.
Yeah, usually means I made a typo somewhere. But how do we handle these gracefully, so our program doesn't just crash and burn?
Well, the article mentions a few approaches. You can use the get method to provide a default value, just in case the key's not there. Or you can use a try except block, the classic, to catch that key error and handle it in a more controlled way.
So instead of crashing, we can maybe display a friendly error message or something.
Exactly. Or you can just check if the key exists before even trying to use it.
Prevention is always better than a cure, right? So how do we do that?
The in keyword.
Yeah.
Super simple. Check if a key is in the dictionary before you try to access its value. No more key errors.
Love it. Okay, let's talk about how Python handles memory. The article asks, how does Python handle memory management, and what role does garbage collection play? This always seemed a bit mysterious to me.
Behind the scenes stuff, for sure.
Right, I'm glad Python takes care of it automatically, but I'd love to understand how it actually works.
So Python uses this thing called a private heap to store all the objects in data structures. Think of it like a giant warehouse where all your program stuff is stored. And the memory manager is like the foreman of this warehouse, allocating space for new objects as they come in.
Okay, I can picture that. So what happens when those objects are no longer needed? Does the warehouse just keep getting bigger and bigger?
That's where garbage collection comes in. It's like a cleanup crew,
Yeah.
right? It goes through the warehouse, finds any objects that aren't being used anymore, and tosses them out. Frees up space for new stuff.
Recycling for our code. Love it. Okay, the next question dives into something that often trips me up. What is the difference between shallow copy and deep copy in Python, and when would you use each?
This is a big one, especially when you're dealing with those, nested data structures, like lists within lists or dictionaries within dictionaries.
Okay, so like layers of data.
Yeah, exactly. Think of it this way. You've got a box, right?
Mm-hmm.
And inside are several smaller boxes, each with their own stuff inside. A shallow copy, it makes a new box, but it just copies references to those inner boxes. So if you change something inside an inner box in the copy, it changes the original too.
Oh, wow, so it's like they're linked.
Exactly. But a deep copy, that makes entirely new boxes and new contents. So any changes you make in the deep copy, totally isolated from the original.
So it's like the difference between sharing a Google Doc and making a copy of it. If I share it, any changes I make, everyone sees. But if I make a copy, I can edit freely without messing things up for anyone else.
Perfect analogy. So if you need a truly independent copy, deep copy is the way to go.
Deep copy for when we want to be extra careful. Got it. Now let's explore this. How can you use Python's collections module to simplify common tasks? I've heard good things about collections, but haven't really dug in yet.
The collections module is like this toolbox filled with specialized data structures. Super useful stuff.
Okay, so what kind of tools are we talking about? Give me some examples.
One of my favorites is the default dict. It's like a regular dictionary, but with a superpower. Imagine you're counting how many times each word appears in a text, right? With a regular dictionary, you'd have to check if the word already exists as a key before you increment its count. But with default dict, you can specify a default value like 0. So if the key doesn't exist, boom, it's automatically created with that value. No more checking.
That sounds super handy, like a dictionary that automatically fills in the blanks. What else?
Well, there's the counter. It literally does what it says. Counts things. You give it an iterable, like the list of words, and it spits back a dictionary with each unique element and its count.
So if I wanted to analyze word frequencies in a text, counter would be the way to go.
Absolutely. Perfect for that kind of thing. And then there's the dec, which stands for double-ended queue. It's like a list, but optimized for adding and removing stuff from both ends. Perfect for implementing queues and stacks. Those are common data structures in computer science.
Okay, so we've got tools for default values in dictionaries, counting, queues, stacks. It's like a Swiss Army knife for data structure.
Exactly. Collections. It's a great example of how Python provides these high-level abstractions to make our lives easier. We can focus on what we want to do, not get bogged down in the low-level details.
Love that. All right, are you ready for some more advanced questions?
Hit me. Let's do it.
Okay, this one sounds intriguing. What is the Python with statement designed for? I've used it before, especially when working with files, but I'm not sure I fully understand what's going on under the hood.
The with statement, it's all about making our code cleaner, safer, especially when you're dealing with resources that need to be opened and closed properly, like files or network connections. It just makes sure that those resources are, acquired and released correctly, even if errors happen along the way.
Oh, so it's like a safety net.
Exactly. Like imagine you're working with a file, right? Without the with statement, you have to manually open it, read or write stuff, and then remember to close it. But if an error happens before you close it, resource leak.
Sounds messy.
Yeah. So the with statement uses this thing called a context manager. It's like having this dedicated assistant that handles all the setup and cleanup for you. You can just focus on the core logic of your code.
Elegant. And much less prone to errors. Okay. I'm liking the with statement more and more now. What's next?
Let's demystify decorators. The article asks, what are decorators in Python? They sound fancy, but I'm not always sure what they actually do.
Me too. Something to do with functions, right?
Yeah.
But the details are a bit fuzzy.
Think of decorators as functions that enhance other functions. They add functionality without changing the original function's code. Kind of like adding a turbocharger to a car's engine. You get a performance boost without messing with the engine itself.
Okay, so instead of changing the original function directly, we can wrap it in a decorator to give it extra features or behavior.
Precisely. You could have a decorator that logs every time a function's called, or one that measures how long it takes to run. All sorts of possibilities.
That's cool. So the original function stays nice and clean, and the decorator adds its magic externally. Love it. What about context managers? The article also asks, what are context managers in Python and how are they implemented?
Context managers, they're the unsung heroes behind that with statement we were just talking about. They provide a structured way to manage resources, making sure everything's properly set up and cleaned up no matter what.
So they're like the stage crew, right? Setting up the stage before the play and cleaning up afterward.
Exactly. And to create one, you define two special methods in your class, enter and exit. Enter handles the setup, like opening a file, and exit handles the cleanup. This all happens automatically, regardless of what happens inside that with block.
So context managers, they're all about making sure things are handled properly before and after a certain chunk of code executes. Built-in insurance. Love it. Now, are you ready to get meta?
Let's get meta.
Okay, this question always throws me for a loop. What are metaclasses in Python, and how do they differ from regular classes?
All right, time to go deep. So, in Python, everything is an object, even classes themselves.
Whoa, mind blown.
Right. So a metaclass is a class that defines the behavior of other classes. Think of it like this. If a regular class is a blueprint for creating objects, a metaclass is a blueprint for creating classes.
Okay, that's getting pretty abstract.
It is. Metaclasses, they're like the architects of classes, dictating how they're created and how they act. Super powerful stuff, but not something you'd use every day.
More of a specialized tool then?
Exactly. Okay, back to data science. The article asks, what are the advantages of NumPy over regular Python lists? Again, guess this is really important.
It's a recurring theme for sure. But I'm always up for hearing more about NumPy. It's such a workhorse.
It really is. And we did touch on this before, but it's worth emphasizing. NumPy arrays, they are the foundation of numerical computation in Python.
And they're much more memory efficient, right? Can you talk more about that?
Sure. So NumPy arrays, they store elements of the same data type right next to each other in memory. It's like having a really organized toolbox where all the tools are in their designated slots. Python lists, they can have different types of objects scattered all over the place. NumPy's organization makes things much faster.
Compact and efficient.
Yeah.
And that leads to faster processing speeds, right?
You got it. NumPy has all these optimized algorithms for number crunching, makes it lightning fast.
Like using a supercomputer versus doing calculations by hand.
Exactly. And don't forget, NumPy has a huge library of functions for, like, array manipulation, linear algebra, you name it.
It's like a data scientist's dream come true. The article then asks, what is the difference between merge, join, and concatenate? Operations for working with data frames in pandas. I'm guessing these come up a lot when you're dealing with, like, real-world data.
All the time.
Yeah.
They're the bread and butter of data manipulation. So merging, think of that like joining tables in a database based on a common column. You're basically linking data from different sources, but based on a shared characteristic.
So if I had one table with customer information and another with their order history, I could merge them based on the customer ID column, right? Get a complete picture.
Exactly. Now, joining is similar to merging, but it specifically combines data frames based on their indexes, like aligning two data sets side by side, but using those row identifiers to match them up.
Okay, so merging uses shared column values. Joining uses matching row labels. What about concatenation? Is that just sticking data frames together?
Pretty much. Like gluing two pieces of paper together, you're just combining them. No fancy alignment based on columns or indexes.
Yeah, got it. Merging, joining, concatenating, all for different scenarios. Now, what about missing data? The article asks, how do you identify and deal with missing values? This feels like a problem every data scientist has to face.
It's the reality of working with real-world data. It's messy.
Right. Never perfect. So first things first, how do we even find those missing values?
Pandas has this handy function called isNull. It basically gives you a data frame that highlights all the cells with missing data.
Like a treasure map, but for missing data. So once we've found them, what do we do?
Well, one option is to just drop those rows or columns with missing values, but that can be risky. You might lose important information, especially if those missing values aren't random.
So don't throw out the baby with the bathwater. What's a better approach?
Imputation.
Imputation. Okay, that's a new word for me. What does that mean?
It's like filling in the blanks, but you do it intelligently. You use statistical methods to estimate those missing values based on the data you do have.
So instead of just deleting data, we can try to fill in the gaps in a way that makes sense statistically.
Exactly. It's a crucial skill for data scientists. And speaking of skills, the article comes back to data visualization with this question. Which all Python libraries have you used for visualization? They really want to know if you can make those charts and graphs pop.
I guess being able to communicate insights visually, that's super important. We've already talked about Matplotlib, Seaborn, Plotly, and Bokeh. Anything else worth mentioning?
Those are definitely the heavy hitters, but there are others that data scientists often use, like ggplot2. It's a super powerful plotting system based on this idea of the grammar of graphics. Very flexible, creates some really beautiful plots.
ggplot2, that rings a bell. Isn't that originally from the R world?
You're right, but there's a Python implementation called Plot9 that brings that same approach to Python.
So if you're comfortable with R, you can still use a familiar plotting system in Python. Cool. What about interactive visualizations? Anything besides Plotly that shines in that area?
Bokeh, we talked about earlier, remember? Great for interactive stuff, especially when you have large data sets.
So many options for bringing data to life. It's awesome. Okay, are you ready for some more coding challenges?
Absolutely. My Python muscles are ready for a workout.
Okay, here's one. How can you replace string space with a given character in Python?
Sounds straightforward enough. You could just loop through the string, check if each character is a space, and if it is, replace it.
Yeah, that's what I was thinking.
But there's a more Pythonic way. Remember list comprehensions. We can use those to create a new list with those spaces replaced, and then just join them back into a string. Super efficient.
Ah, list comprehensions, Python's secret weapon for writing concise and elegant code. Okay, hit me with the next challenge.
Okay. Given a positive integer, write a function that returns true if the number is a perfect square, else false.
So we're basically checking if a number has an integer as its square root. We could calculate the square root, convert it to an integer, and then square it again. If it matches the original number, boom, perfect square.
Exactly. Simple and effective. Sometimes the most elegant solutions are the most straightforward ones.
I'm starting to see that. It's all about understanding the core logic and then translating that into clear, concise code. Okay, what's next?
Given an integer n, return the number of trailing zeros in n factorial. Yeah, remember factorials?
Oh boy, factorials. Those can get pretty big pretty quickly.
Yeah.
So we first need to calculate the factorial and then figure out how many zeros are at the end.
Right. And the article gives this really clever solution. You convert the factorial to a string, reverse it, and then count the number of zeros at the beginning.
Reversing the string, that's a neat trick. Makes it way easier to count those trailing zeros.
Thinking outside the box. Okay, ready for a word puzzle?
Love word puzzles. Bring it on.
All right, here it is. Can the string be split into dictionary words?
Okay, so we've got a string and a dictionary of valid words, and we need to see if we can break that string into a sequence of words that are all in the dictionary.
You got it. And the article suggests a recursive approach. You basically try all possible split points in the string, check if the left part is a valid word, and then recursively check if the rest can also be split into valid words.
It's like trying to fit puzzle pieces together. We keep breaking it down until we find a solution or hit a dead end.
Exactly. Recursion could be super powerful for problems like this. Okay, here's one we've seen before, but with a twist. Can you remove duplicates from a sorted array?
Wait, haven't we already solved this? We did the two-pointer method earlier.
We did. But this time, we have to do it in place. Remember, no creating a new array.
Right. We got to be even more efficient with our memory usage.
The article mentions a solution using, you guessed it, two pointers.
Wait, so the same approach works for both?
It does. The two-pointer method is just that versatile.
That's amazing. Okay, hit me with another one.
All right, let's try this math puzzle. Can you find the missing number in the array?
Okay, a missing number. Intrigued. What's the scenario?
So you have a list of numbers from 1 to n, but one's missing. Got to find it.
Classic brain teaser. So how do we crack this one?
The article uses this really elegant solution that uses, get this, the formula for the sum of an arithmetic series. Remember that from math class.
Vaguely. Something about n times n plus 1 divided by 2.
That's it. So you calculate the expected sum of the numbers from 1 to n, and then you just subtract the actual sum of the numbers you have, the difference. That's your missing number.
So simple, yet so clever. I love it.
It's all about connecting those dots between math and coding. Okay, one more.
Yes, please. I'm on a roll.
All right. This one's a classic. Find the first non-repeating character in a string.
Okay, so we have a string, and we need to find the first character that only appears once. I could see this being useful for all sorts of things.
Absolutely. The article uses a dictionary to keep track of how many times each character appears. Then it just walks through the string again, checks the count for each character, and boom. The first one with a count of 1, that's our winner.
That's really clever. Using a dictionary to make the search more efficient. I'm loving these coding challenges. It's not just about memorizing algorithms, it's about problem solving.
Exactly. That's what makes it fun, right?
Welcome back, everyone. We're on the final stretch of our Python interview question deep dive.
We've covered a lot of ground, that's for sure. From the basics to some pretty tricky algorithms.
Yeah. But we've saved some of the most interesting questions for last. Now the article, it shifts gears a bit. It starts to focus on those, those brain-bending questions you might get at companies like Google, Facebook, Amazon, those big tech giants.
Yeah, those companies, they're known for their really tough interview processes. They really want to see how you think, how you approach problems.
I'm a little nervous, not going to lie, but also kind of excited to see what they're throwing out there.
Their interview questions often give you a glimpse into the real world stuff they're working on, which is pretty cool.
Totally. Okay, so let's dive in. This first one sounds like it came straight from Wall Street. Can you find the maximum single cell profit?
Ooh, that's a good one. So we're talking about stock trading, trying to figure out the best time to buy and sell to make the most money, but you can only buy and sell once.
Exactly. Imagine you have this list of stock prices over time. The challenge is to find that sweet spot to buy low and sell high.
Yeah, the optimal buy and sell points to maximize your profit. Every investor's dream, right?
For sure. So how do we approach this?
The solution in the article, it involves going through those prices one by one, keeping track of the lowest price you've seen so far, and then the maximum profit you could make at each point.
So it's kind of like a treasure hunt, right? Always looking for that better buying opportunity and then figuring out how much you could make if you sold right now.
Exactly. It's a balance, right?
Yeah.
Finding a low buying price and then being patient, waiting for that perfect moment to sell high.
Love it. Okay, this next one sounds like a geometry problem. Can you find a Pythagorean triplet in an array? Oh, this takes me back to high school math.
Pythagorean theorem. A squared plus b squared equals c squared.
Right. The classic 3, 4, 5 triangle.
Exactly.
Yeah.
So in this problem, you're given an array of numbers, and you got to find 3 numbers that fit that pattern. Make a right triangle.
So it's like a number puzzle, but with a geometry twist. How do we solve this one?
The article, it does this cool thing. It squares all the numbers in the array first, then sorts them. And then it uses a nested loop, which can be kind of tricky, but it checks for those triplets that satisfy the Pythagorean equation.
So it's like sifting through the numbers to find those special combinations? Clever. Okay, this next one sounds familiar. How many ways can you make change with coins and a total amount? I feel like we've seen this before, haven't we?
We have. It's that classic dynamic programming problem, remember?
Yeah.
But it's it pops up in all sorts of different forms.
Yeah, figuring out how to pay for something with the right combination of coins. I remember this one being really tricky when I was first learning to code. How does the article approach it this time?
Well, they build a table that, like, systematically stores the number of ways to make change for each amount. Working your way up to that target amount using whatever coins you've got.
Step by step, building up that solution.
Exactly. Okay, let's shift gears a bit and talk about some core Python concepts. This one's from the article. Define a lambda function, an iterator, and a generator in Python. It's like Python vocabulary time.
Love it. Okay, let's start with lambda functions. Those are like anonymous functions, right?
You got it? Small, self-contained pieces of code. They don't need a formal name. You just use them on the fly.
So perfect for quick calculations or things like that.
Exactly. Now, iterators, those provide a way to access elements in a sequence, like one by one, without needing to know how that sequence is actually stored under the hood.
Okay, so like a simplified way to work with sequences.
Yeah, think of it like you're on a tour through a museum, right? The iterator is your tour guide, showing you each exhibit in order. You don't need to worry about the museum's layout. You just follow the guide.
Great analogy. And generators, those are a special type of iterator, right? What makes them special?
Generators, they create values on demand, as you need them, using this keyword, yield. Like imagine you have this magic box, and every time you open it, boom, a new item appears.
So you don't have to store all those items ahead of time, just generate them as you go.
Exactly. Super efficient, especially for working with, tons of data.
Awesome. Okay, I'm glad the article brought up this question. Are there free resources to prepare for Python interviews? Because, we're all about making learning accessible to everyone.
Absolutely. DataCamp itself has a ton of free resources like courses and tutorials, and there's so much great stuff out there online, coding challenge websites, online communities, you name it.
So no excuses. There's a wealth of knowledge waiting for you if you're willing to put in the effort. All right, let's wrap up with one final question that really highlights just how versatile Python is. What are the 5 main uses of Python?
Oh, this one's wide open. Web development, scripting, desktop applications, data analysis, machine learning. The list goes on and on. Python is everywhere.
It really is. I think it's, it's the readability, the huge ecosystem of libraries, the awesome community. All of that makes it so popular.
It's a language that really empowers people to build amazing things.
Couldn't have said it better myself. Well, folks, that brings us to the end of our Python interview question deep dive.
We've explored the fundamentals, tackled those tricky algorithms, and hopefully given you some insights into what those interviewers are looking for.
Whether you're a seasoned Python pro or just starting out, remember, keep learning, keep practicing, and never stop exploring the incredible world of Python.
Couldn't agree more. And thanks for joining us.